All right, hello everyone. So I'm Yanni, and along with my colleagues Matheus and Drake, we will be discussing an inevitable part of text mining and data analysis, the importance of removing stop words throughout the textual analysis process. So let's get started with a quick introduction. So first, we need to talk about what text analysis really is. Text analysis is essentially the art of extracting valuable insights and information from written text. It's like mining for gold in a mountain of words. In fields like academia, business, and data analysis, text analysis is indispensable. It helps us do things like gauge public opinions through sentiment analysis, organize vast amounts of data with topic modeling, and retrieve specific information efficiently. Now that we know what text analysis is, let's discuss stop words. Stop words are the noise in our textual data that carries no contextual significance or meaning for analysis purposes. So basically, think of words like the, is, for, of, to, and so on. These are the usual suspects when it comes to stop words. They're abundant in the text, but add little to no value in terms of understanding the content. While these words are crucial for grammar and sentence structure in written documents, they don't really contribute that much to the overall meaning of the document itself. They're like the glue, basically, that holds the sentences together, but doesn't reveal much about the message. Overall, understanding stop words is key to effective text analysis. Through filtering them out, we are able to put our focus on the information that carries significance to our text analysis process. So now let's talk about the importance of removing these stop words. So removing stop words is done in the pre-processing step of data analysis. The first reason why the removal of stop words is so important is because it reduces the computational load and storage requirements of your machine. Through removing these unnecessary words from the text data, we're essentially streamlining the process. As the machine will now have fewer words to process, our resources can focus on the meaningful content at hand. This saves time and reduces the strain on computing systems. Also, who doesn't want to work with a dataset that is cleaner, easier to work with, and easier to interpret? Also, the training time whenever you deal with machine learning will also decrease. The training process becomes more efficient, allowing for quicker iterations and experimentation with different models and parameters. Next, stop words contribute to the noise in our textual data. Reduction in noise is crucial for increasing the accuracy of machine learning models and search engines. As the algorithm will become more focused and cleaner, we would also anticipate that they provide more accurate predictions and search results. Removing stop words helps us cut through the noise and extract the essential information, which is ultimately what we want so that we have more precise and reliable analyses, which we can do so much with. To summarize the slide, removing stop words is not just about cleaning up the data. It's about enhancing the accuracy and effectiveness of our text analysis processes. By reducing computational load and storage requirements, reducing noise, and increasing the accuracy of machine learning models, removing stop words plays a crucial role in improving the quality of text analysis results. So now I will pass it on to Mateus, who will go over the various techniques and the how-tos on removing these stop words.
Hello, my name is Matheus, and I'll be talking about techniques for removing stop words, and I'll be also showing some examples of those techniques in some notebooks that I have here. And first of all, I just want you guys to know that I have two screens here, so if you see me looking this way, it's just because I have two screens and I'm always like changing to make sure that I can present the best way I can. So, in text analysis, the presence of stop words can introduce noise and hinder the extraction of meaningful insights from textual data, as the previous presenter talked about. So, by utilizing effective techniques for stop word removal is essential for enhancing the efficiency and accuracy of text analysis. And now I'm going to show you some, or we're going to explore some of the various techniques. I'm not going to show each one of them here, just a couple. I think I have four. so you guys can have an idea what I'm talking. So the goal here is to empower you to optimize your text analysis workflows and unlock deeper insight from your data. Okay, so the first one is the manual removal. So manually removing stop words involves creating a custom list of words to exclude from the text. This method offers flexibility but can be time consuming and subjective, as I'm going to show you in a bit. So analysts can tailor the list of stop words to their specific domain or context, providing control over the text uh, pre-processing process. So now I'm going to show you uh, some examples here that we have. So I created this text so we could uh, use some of the techniques that we're going to see here. And the first one is the manual removing. So I have my list of stop words here, and then I have a function that remove the remove the words from the text. And then after I process, you guys can see that I don't have the in because the in is going to be here. So this is a manual removal of stop words. So it's in a very specific case that you need that. You just create a list and then you remove the words by using just simple Python code. Okay. So if we go back now, we can talk about the predefined stop word lists. So predefined stop word lists are created sets of common stop words provided by libraries such NLTK or SPACY. Uh, these lists are based on linguistic research and contain words that typically do not carry significant meaning in text analysis. And by utilizing predefined stop word lists, streamlines the process of stop word by removing stop word removal by eliminating the need to manually specify each stop word. So instead of creating an array of words, we can just use for this example. For example, I'm using spaCy, uh, but it has some of the it already has this function here with a list of stop words, and then not sure if this is going to run. Do I need to wait? It's perfect. So here I just printed like some of the words that usually that are present that are present in the spaCy library. So here, and then we have the same thing, the original text and the pre-processed text without the in, for example. So, and then I also printed here the stop word so we could see how this list looks. And it's a big list with the words that spaCy defined by research that are stop words. Okay, so now we can talk about the frequency-based removal. So frequency-based removal involves removing words based on their frequency of occurrence in the corpus. Words that appear too frequently in more than 90% of documents or too infrequently in less than 5% of documents are considered stop words and are removed. So this technique helps eliminate noisy and less informative words from the text corpus, improving the quality of the text. So I also have an example of that here. And for that, I'm using LOTK. So we can just run this here. Um, and when we do that, we can also see uh, some of the words that are removed here and the processed text. This one is a little bit different, but has its own use case too, and it's using by how many times a word is presented in that text or how many times it's not. Um, okay, so now we can talk about part of speech tagging. So part of speech tagging assigns grammatical categories, for example, nouns, verbs, to words in the text. So that is like a pre thing, a thing that you do before doing the stop word, so you can identify which words do you have in your text. So I'm also using spaCy for this one, I believe, and then here we have like this is And all those letters here, they have like meanings, of course. So this is a noun. Um, this is a comma here, so it's a punctual. And this can help you to understand your text for further to do some of the uh, removing words later in your process. So part of speech tagging, it's really interesting and it can help you to identify what your text is, how it was created, and what are the roles of each words inside your text. And last but not least important, we have the machine learning based approaches where uh, use vector machines or neural networks that can be trained to classify words as stop words or non-stop words based on contextual features. So these models can then automatically remove stop words from the text, leveraging contextual information to identify irrelevant words. So that's like the smartest way to do this, where you have like some vector machines or neural networks analyzing your text and seeing what are stop words or not. So this you can be a little bit more effective. We don't have any example of that in in Python here, but it's just to give you an idea that things that you can do with it. So it offers automation and adaptability, like I said, allowing for more dynamic stop word remover tailored on the specific characteristics of the text corpus. That's it. Thank you.
All right. Hello, everyone. My name is Drake. I'm going to be going over a demonstration of these stop word techniques, some of the ones that Matheus presented for us, and how we can see it in a real example, and do kind of like a side-by-side experiment of what NLP would look like if you did not remove the stop words versus what it looks like when we do take them out. So moving over to my Colab notebook here, and I've pre-run all of these code sections so that we can see them all done already and don't have to wait for it to process. So first thing I have here, importing the natural language toolkit into Python. They have their own predefined stop word list, which makes it very convenient to use out of the box. I printed it out here for us to see what's in it. And you can see it's your pronouns. There's a lot of prepositions. The verbal modifiers like the conjugations of to be, of have, and do are in there. Conjugations of that, conjunctions, um, uh, and somewhere in here is the articles and indefinite articles too. Your and a, and the, all the common words that we want to remove. And towards the end of this stop word list, they also have these conjunctions as well as some misspellings of them that are kind of common, it seems. So what we'll actually be looking at as our text is this big data Wikipedia article. The topic of the class seems fitting to use it as our sample text. There's actually a Wikipedia API you can use to directly import text from Wikipedia and use it in your Python program. So we installed that API and then used this section here to import the big data article. You actually can just enter the title of the article in quotes like this, and the API will be able to import it for you. So we assign that to article 1 text, printed it out for us to see here, and you can see the whole article in its form. And this is just text with no images, as you can see. So first step was to clean this data, and we made this little function here to simply remove the punctuation and make everything lowercase. This creates our clean text here, text underscore cleaned. Same article, same format and everything, but the text is all now uniform in that it's lowercase and the punctuation has been removed. And this sets the stage for us to then actually remove the stop words from the cleaned data. Again, we're just using that predefined stop word list from NLTK. Using this function here, we're able to remove all of those and create our text with no stop words. And it's the same as far as keywords, but as one scans through the text, you can see those unnecessary words as far as the machine is concerned being removed. I then tokenized all of those stop words and or rather I tokenized the article without the stop words, I should say, and tokenized the article with stop words, and then printed these both out side by side, the list of tokens, so that we can see the difference. And when it starts out, big data primarily refers, then we start seeing these stop words show up, and you can see how it, one, really increases the length of the corpus of text, and two, as such, a lot of these are going to keep appearing more and more and more. Like in the first sentence here, we have two appearing multiple times. That's going to start diluting those keywords. And so when the machine is looking at the tokens with the stop words there, it's going to be limiting the impact of what it's seeing. And so to demonstrate that more clearly, I have this segment of code here to show us the frequency of the most common tokens appearing. We're doing the top 25 of the tokens with stop words and the tokens without stop words, which I have appearing on top of each other here. So the top is without and the bottom is with. And you can see with the stop words kept in the text, we have V being the most common token appearing. And what is really the most important issue or most important topic in this article is data, is the concept of data and big data secondarily, big being number 2 on the list here. And I'm sure the 194 times it appeared, it was modifying data to being big data. But on our list with the stop words, data is pushed to number 2 behind the, and big is number 1, 2, 3, 4, 5, 6. And then information is actually number 3, appearing 36 times on our token list without stop words, but it's a long way down the list on the items with stop words. And you can see all of these stop words we took out are the most common tokens appearing when they're still in the article. And that means a lot of concepts like science, like analytics, like development here, challenges, or volume or internet, those aren't even appearing in our top 25 list anymore because these stop words are kind of taking up a lot of space, creating a lot of traffic, if you will. This little experiment of showing them side by side too also kind of sheds light on the fact that although removing these stop words from a predefined list is very useful and it's extremely convenient, these code sections we have here are not complicated at all. On the final list, there still are a lot of filler words that aren't crucial to the meaning of the article, like may, like used, use, and I believe I saw using further down the list here. Using is down here with 16 instances, also as a preposition. A lot of words like that are not really keywords to the meaning in the article. And that shows that these predefined stop word lists are not perfect, and it probably would be a good idea if you're doing some serious work on some body of text to perhaps start with one of those predefined stop word lists and then begin expanding them with other words you keep seeing show up. And there might be certain specific words based off of what specific type of text you're looking at, maybe a genre of literature or some certain industries usage of language might differ, and they might have more common stop words that don't appear in these generic lists that you would want to identify and then remove and make yourself a kind of more robust stop word list to get a more meaningful extraction of these key tokens in the end.